So today we're going to look at algebra word problems. We're going to look at number problems first. Number problems always are the type of problem where you see these kinds of instructions in the problem. A number, a certain number, an unknown number. The key idea here being that there is a missing number that you're going to try to find by setting up an algebra equation. Here's a very typical example one right here. The sum of three numbers, again, unknown numbers, is 92. The second number is 8 more than the first, and the third number is twice the second. Find the numbers. You start all word problems basically the same way. You define what your variable is. I've been telling my students that this will actually be at least half a mark on their test. Easiest half mark you ever got from me is this kind of problem right here, where let x equal the first unknown number. Now there's three numbers I'm looking for. Why did I say x should be the first number? Well, because look at the way the wording looks. The second number is 8 more than the first. How do I say 8 more than the first algebraically? Well, I would say it like this. The second number is obviously 8 more than the first. Well, the first was x. 8 more than that is plus 8. Please notice it is not multiplied by 8. 8 more than something is just an add, not a multiply. The next piece of information tells me the third number, so the third number is twice the second. How do I do twice the second number? Well, the second number was again x plus 8. And if I want twice that, twice means I have to times it by 2. Why am I timesing it by 2 in a bracket? Because the entire value, x plus 8, is one number to me, and I have to times all of it by 2 if I want twice that amount. Now, I've defined my variable and my three numbers. How do I get an equation out of that? That's the key word there. The word sum is telling me to add. So I am going to add the first number to the second number to the third number. And what do I know about that sum? It is, which means equals, 92. And that's where my equation comes from. From there, most of my students can handle this pretty easily by now. We've done quite a bit of practice on just equation solving so far. So 1x plus 1x plus, I think I'll multiply that out first before I do anything. I'll do the distributive property on it. 2 times x is 2x. 2 times 8 is 16. 1x plus 2x is 4x plus 8. Oh, wait a minute. Might as well add those together while I'm at it. 8 plus 16 is 24. And now it looks just like the kind of algebra you did in grade 8. A type 2 equation. 2 more steps and I'm solved. The first step is I'll minus the 24 from both sides. 92 minus 24 is 76? Nope. 66. All right about that? 8, no. How about 68? Thank you very much. Minor error there. And yeah, 68 plus 24 is 92. Then the last step to solve this is to divide both sides by 4. 4 goes into 68, 4 goes into 6 once, and 17. And then if I stop there, I would probably lose for sure half a mark, maybe a whole mark on my final answer, because every word problem should end with a sentence. It doesn't have to be a grammatically great sentence. In fact, start it with this little shortcut that means therefore. Therefore, the numbers are, remember I was looking for three numbers, and the x represented, if you look back, the first number. Quickly scroll back. What was the second number again? Oh yeah, the second number was 8 more. So the second number was 25, and the third number was twice the second number. So there's my three numbers. And to do a quick check, what do I know about these three numbers? Oh yeah, they should have a sum of 92. Solved. Okay, one more example of this type of problem. There are 4 numbers. The first is 20 less than the second. The third is 1 more than twice the first, and the fourth is 4 more than the second. We also know that the sum of the first and second equals the sum of the third and the fourth. Find the numbers. That's a lot of English to plow through, but once you take a look at it, again, you have to start with defining what your variable means. The first is 20 less than the second. The third is 1 more than twice the first. I think I might just say let x equal the second number. I don't have to do it that way, but I've just decided to, because then the first number, the first is 20 less than the second. How do I say 20 less than x? X minus 20. So that takes care of the second number and the first number. The third number is 1 more than twice the first. Well, the first was x minus 20, and it's twice that plus 1. 1 more, that's the plus 1, than twice the first. And the first number is x minus 20. Twice that means times it by 2. Finally, the fourth is 4 more than the second. So the fourth number is 4 more than the second number. There's my 4 numbers. That second sentence tells me everything I need to know about the 4 numbers. But the next sentence, the third one, tells us how they relate to one another. The sum, that means I'm adding, of the first and the second, which is right here, x, equals the sum of the third one and the fourth one. And there's how you get one of these word equations where x ends up on both sides of the equal sign. And whoops, somebody just pointed out to me I forgot the plus 1. That little plus 1 got lost. There we go. And the fourth. There we go. Now we're rolling. All of that has to become one thing. Somewhere there is a number in this universe that if you take that number, take 20 away from it, add it to the same number again, you get the same thing as if you took that number, took away 20, doubled that answer, added 1, added that same number again, and added 4. And my job is to figure out what that number is. Man, I love equation solving. Okay, 1x plus 1x is 2x minus 20. Over on this side, I think I'm going to simplify this first with my distributive property, 2x minus 40. And plus 1 plus 4, I know that's a plus 5, plus x. Okay, I still have some simplifying I can do on the right-hand side. 2x is plus 1x is 3x. And negative 40 plus 5 is negative 35. All right, next step, I'd need to get all my x's to one place. So I'm going to minus 3x from both sides of the equation, giving me negative 1x minus 20 equals negative 35. Now I need to add 20 to both sides of the equation. So negative 1x is equal to negative 15. And a lot of people would stop there and say x is negative 15, but don't forget, I don't want to know what negative x is. I want to know what x is. So my last step is to actually divide both sides by the number in front of x, which is negative 1. So x is positive 15. Now, once again, that's not done yet. I'm supposed to find 4 different numbers. That's only the second number. So let's make a quick, therefore, the numbers are, and I know the second one is the one I just defined as my x, which is 15. Go back to my original statements there. The second number was x. The first number is x minus 20. So the second number is, or the first number is 15 minus 20. It's negative 5. It didn't say these numbers had to be whole. So don't be surprised you got an integer for this one. Going back up, what do we know about the third number? The third number is the most complicated one. It's 2 times x minus 20 plus 1. So I might do that as scrap work over here. 2 times x minus 20 plus 1, and my x is 15. Good thing we've studied BEDMAS this year because we kind of needed it. 15 minus 20 is negative 5. Negative 5 times 2 is negative 10. Negative 10 plus 1. My third number is negative 9. And lastly, my last number is the second number plus 4. So my x plus 4. So my fourth number is 15 plus 4. So there's my final solution. And again, I can do a quick check because the first two are supposed to add up to the same thing as the third and fourth. Negative 5 plus 15 is 10. Negative 9 plus 19 is 10. Solved.